Backfilling procedure in oil and gas, petrochemical industry, Part 1, General. Introduction. Construction site with backfilling procedure. Clearing and preparation before backfilling. Ensure that the construction area is clear of debris and vegetation. Remove any obstructions that could interfere with the backfilling process. Foundation inspection. Inspect the foundation or structure to verify its integrity. Ensure that any required waterproofing or drainage measures are in place and functioning correctly. Gradation and compaction. Backfill materials should be appropriately graded and compacted. This involves placing the material in horizontal layers and compacting each layer to the specified density. Thickness control. Maintain control over the thickness of each backfill layer. Typically, cohesive soils should not exceed 200 mm, while cohesionless soils should not exceed 300 mm in thickness after compaction. Moisture control. Monitor and control the moisture content of the backfill material. Avoid compacting soil with moisture content that varies more than 3% from the optimum moisture content. Key points to consider. Drainage system. Ensure proper drainage to prevent water accumulation around the foundation or structure. Implement drainage solutions such as surface drains or French drains as needed. Grading. Slope the ground away from the foundation or structure to encourage water runoff and prevent pooling. Waterproofing. For below-grade foundations, consider waterproofing measures to protect against moisture penetration. Backfill material. Choose backfill materials that promote drainage and do not retain excessive moisture. Proper compaction is essential. Permeability. Consider the soil's permeability and implement additional drainage measures if necessary. Groundwater level. Assess the groundwater level, especially in areas with high water tables. Plan for dewatering systems if needed. Soil testing. Conduct soil tests to assess soil properties, drainage characteristics, and suitability for backfilling. Welcome to the educational video series on backfilling procedures in the oil and gas and petrochemical industry. In this Part 1 video, we'll dive into the essential aspects of backfilling, ensuring the structural integrity and stability of various construction elements. Description and scope. Setting the stage. Before we get started, let's clarify what we're dealing with. This section covers the essential aspects of backfilling as required by the contract, including the general provisions, conditions, and specifications. What's included? Inclusion checklist. We're about to take a closer look at what's included in this backfilling procedure. Backfilling around building perimeters and site structures up to subgrade elevations. Filling under interior and exterior slabs on grade. Consolidation and compaction of the backfill. Fill material for over-excavation. Related sections and references. Building connections. In the construction world, things are interconnected. Here are some important references and related sections. Section 02320, Excavation Reference for excavation work. References for quality. Quality matters. Here are some references that guide our backfilling process. AASHTO T180 and ASTM D698, Standards for Moisture Density Relations of Soils and Compaction Characteristics. ASTM D1556 and ASTM D1557, Standards for Density of Soil in Place. ASTM D2167, Standard Test Method for Density and Unit Weight of Soil in Place. ASTM D248700, Standard Classification of Soils for Engineering Purposes, Unified Soil Classification System. ASTM D2922 and ASTM D3017, Standards for Density and Water Content of Soil and Rock in Place by Nuclear Methods. ASTM D4253, Standard Test Methods for Maximum Index Density and Unit Weight of Soils using a Vibratory Table. Section 4, Materials. Choosing the right materials. The success of backfilling relies on the materials used. Here's what we consider. Structural fill: clean, durable, granular material, free from organics, and meeting specific gradation criteria. We even classify it based on its suitability. Ordinary fill: well-graded natural soil, free from organics, weak materials, or stones larger than 15 millimeters. Water and quality control: 1 minute. Staying hydrated. Water is an essential ingredient. We ensure an adequate supply of water for construction. Ensuring quality. Quality control is non-negotiable. We partner with soil testing laboratories to perform essential tests and ensure materials meet specifications. Execution: 3 minutes. Putting plans into action. Now, let's get practical. Here's how we execute the backfilling process. Grading for pavements and roads, ensuring proper grading before laying road-based materials. Filling and compacting, proper placement and compaction techniques to meet density requirements. Backfilling against foundation walls, the careful process of backfilling around foundation walls while avoiding damage. Filling and compaction. Filling and compaction demystified. Now, let's delve into the heart of backfilling: filling and compaction. This process ensures that the foundation remains stable and the structures above it are supported correctly. Material selection. The right stuff. The success of backfilling begins with the materials you choose. Let's break it down. Materials for fill and backfill must meet the specifications mentioned earlier. Suitable excavated material from the site, if approved by the engineer, can be used for backfill. Materials suitable for backfilling under exterior slabs, pavings, and general grading must be carefully separated from other materials. Borrowing materials. Borrowing with care. Sometimes, you may need to borrow additional materials. Here's how it works. You can provide additional material if required, and it shouldn't cost the employer extra. Acceptable borrow materials should meet specific criteria as discussed earlier. Representative samples of borrow materials are sent to the engineer for approval, ensuring they align with project standards. Placing and compaction. Building layer by layer. Now, let's get into the nitty-gritty of placing and compacting the materials. Filling materials are placed in horizontal loose layers. Start from the deepest area and work your way to the finished grade. The thickness of compacted layers should not exceed 200 mm for cohesive soils or 300 mm for cohesionless soils. It's crucial not to place fill material where free water is standing or on surfaces that haven't been approved by the engineer. Compaction standards. Meeting the compaction challenge. Achieving the right level of compaction is crucial. Here are the standards we follow. All backfill and compaction, especially under and adjoining structures, must achieve 100% compaction of the maximum dry density. This is accomplished within the specific moisture range determined through laboratory tests. Before backfilling, any existing topsoil with an average thickness of 40 cm within the building sites must be removed and disposed of as specified. Each layer must be compacted before the next one is placed. Do not compact soil when the moisture content varies more than 3% from the optimum moisture content. Maintain moisture content through wetting or drying manipulation. Suspended compaction operations are necessary when satisfactory results can't be obtained due to rain or other unsatisfactory conditions. In some cases, beneficial ingredients like hydrated lime or monohydrated lime can be used to adjust moisture content, reduce plasticity, or improve workability. This should be done as per manufacturer recommendations and approved by the engineer. Quality control in action. Heading: Testing the ground. Quality control is hands-on. We conduct field density tests to ensure each layer of backfill meets specified criteria. Types of soil tests and tools. Digging deeper: soil tests. Let's explore the types of soil tests we conduct during backfilling. Mechanical analysis, ASTM D422/OSHTO T88. Plasticity index determination, ASTM D424/OSHTO T91. Moisture density curve determination, ASTM D1557. CBR test for bearing capacity, when required. Tools of precision. Achieving accurate results requires the right tools. nuclear density gauges, sand cones, vibratory tables, hydrometers. Equipment. Compaction equipment. Use appropriate compaction equipment, such as smooth-wheeled rollers, to achieve the required compaction levels. Potential disadvantages of improper backfilling. Settlement. Improperly compacted backfill can lead to differential settlement, causing structural issues. Drainage problems. Inadequate drainage can result in water accumulation, leading to foundation damage and erosion. Structural damage. Failure to follow proper backfilling procedures can damage foundations or structures over time. Final thoughts. Guiding principles. As we wrap up this educational exploration of backfilling procedures, it's essential to remember that standards and practices evolve over time. What we've discussed here provides a general outline, serving as a foundational understanding of backfilling in construction. Stay informed. Narrator, always keep in mind that industry standards may change or be revised to enhance safety, efficiency, and sustainability. Staying informed about the latest developments is vital for professionals in the field. Empowering knowledge. This video aims to empower you with fundamental knowledge. It serves as a starting point for those entering the construction and engineering domains, emphasizing the significance of good practices. Collaborative success. Together, we're contributing to the creation of safer, more durable, and sustainable structures that benefit society. It's a collaborative effort that spans across disciplines, from engineering to environmental science. Building the future. So, whether you're an aspiring engineer, a seasoned construction professional, or simply someone curious about the world of construction, know that your involvement in understanding backfilling procedures plays a crucial role in building the future. Thank you. Thank you for joining us on this educational journey. Your thirst for knowledge and commitment to excellence will drive innovation and progress in the construction industry for generations to come.